Okay, so I left off talking about this midpoint formula. So we add our x's together and we divide by 2. We add our y's together and we divide by 2, and we write our answer as an ordered pair. So plugging in our x1 and x2, that is 0 plus 6, which is 6, and 6 divided by 2 gives me 3. For my y's, I have 2 plus 4, and 2 plus 4 again is going to give me 6, so 6 divided by 2 is 3. If I think about a graph, 0, 2 is about right here, and 6, 4 is about right there. So the middle point of that line, 3, 3, just right in the middle. Okay, so labeling again, x1, y1, x2, y2, and I'm going to add my x's together. Negative 2 plus 6 is 4, and 4 divided by 2 is 2. 4 plus 4 is 8, and 8 divided by 2 is 4. x1, y1, x2, y2. Okay, adding my x's together. 6 plus negative 6 is actually, getting ahead of myself there, 0, and 0 divided by 2 is 0. My y's, negative 7 plus 3 is negative 4, and negative 4 divided by 2 is negative 2. x1, y1, x2, y2. Negative 11 plus negative 11 is not 0. Negative 11 plus negative 11 is negative 22, and negative 22 divided by 2 is negative 11. 3 plus negative 7, again, we already saw that. That's negative 4, and negative 4 divided by 2 is negative 2. So this one's kind of interesting if we look at it. Negative 11, 3 would be like there, and negative 11, negative 7 would be there. So the midpoint between those two would also have to be on negative 11 and then negative 2, which is about right there. Okay, distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to find my exact answer and my decimal approximation. So I'm going to label again like I've been doing. I just kind of like to set it up first. Okay, so x2 minus x1 and y2 minus y1. 2 minus negative 4 is 6, and 2 minus 2 is 0. That's the square root of 36, which is just 6. Okay, I didn't like that green. It was a little too bright. Okay. So x1, y1, x2, y2. Okay, x2 minus x1, y2 minus y1. The negative negative is going to make a positive for us. So again, that would be 0. And then 4 minus negative 3, again, gives us a positive. So that's 7, which is 49. Square root of 49 is 7. x1, y1, x2, y2. Haven't had to do any decimal approximations yet. Okay. x2 minus x1, 0 again. y2 minus y1, y2 minus y1. Yep, I did it right. Okay, be very careful if you type this part into your calculator, because underneath here, -2 minus 2 is -4. You need parentheses around any negatives that you're using anytime you square it. So -4 times -4 is positive 16. And the square root of that is 4. What color haven't I used? Use this one. Okay, x1, y1, x2, y2. Okay, x2. So x2 minus x1 plus y2 minus y1. And again, this becomes 0. All right. All right, so we didn't have any that came out to be anything other than perfect ones. And I know the exam has some on there. So let's throw in one more. I'm going to do just something off the top of my head. Let's do 1, 2, and -7, 5. Okay, x2 minus x1 squared plus y2 minus y1 squared. So that becomes -7 minus 1 is -8, and 5 minus 2 is 3. -8 times -8 is 64, and 3 times 3 is 9. Adding those together, we get 73. So that would be my exact answer. And I would go to my calculator and 73 would be about 8.5. If you happen to get something like square root of 50, what we can do is break that down to 25 times 2 and 5 times 5 and do what's called the prime factorization. These are prime numbers down here. That means they don't divide any further. The 5 is only 5 times 1 and 2 is only 2 times 1. So then when we have a group, 5 times 5 is 25. Square root of 25 is just 5, so that comes out, and our 2 stays on the inside. Another example for you, like if you had square root of 18, we know that is 9. No, that's not what I wanted to do. Let's do 12. So 12 is 6 times 2, and 6 is 2 times 3. So in this case, we have a group of 2s and a leftover 3. Just wanted you to see it wasn't always a 2 leftover. Sometimes you have the group of 2, which comes out, and then your 3. And obviously, you could put that into the calculator as well. Square root of 12 and 2 square root of 3 are the same exact thing when we have our decimal approximation. All right, moving on. Solving a system of equations. Now, when we have a system of equations where they're both in y equals mx plus b, or really y equals any kind of form, that's when we can just set them equal to each other. So think about it this way. If 100 pennies equals $1, and 4 quarters equals $1. Doesn't 100 pennies equal 4 quarters? Yes, because they're both equal to $1. So we're going to use that same exact concept right here. If y is equal to 2x plus 3 and y is equal to half x plus 6, then 2x plus 3 is equal to a half x plus 6. Oh, I'm out of time.